Good morning, guys. So today we are going to do just a couple more notes, make a few little concept maps, just ways that you can keep your information organized. And you should have, if you have not done so, already either copied the PowerPoint, okay, or printed it, and it should go in the physical science section of your notebook, okay, the first thing. All right, but what we're gonna do today, this is also notes, so it's also gonna go in your textbook, okay? You might want a couple of colors. For me, I'm a visual person, so I like my colors to all be different when I'm looking at notes. And feel free to pause the video anytime you need it to be paused. All right, guys, so we're gonna make just a little concept map, just to kind of keep all of our information about matter together. So this is the first unit in physical science, and I usually just call this unit the introduction to all things matter, because everything that we do, can't see that, everything that we do from here on out is going to be about matter until probably the first 9 weeks. Okay, so we're going to spend a lot of time on matter. All right, so what do you need to know about matter? Number one is that matter is composed of one of two things, either pure substances or mixtures. So I'm going to turn my paper to the side. Okay, I'm going to create a little line for my charts. Okay, and this line is going to tell me what matter is composed of. So I'm going to write that right here. Is composed of, excuse me guys.
Since they have registration money, you can go to the library. They sponsor school fees. Please go to the library. And thank you.
Okay, sorry y'all, that's probably going to happen a couple times. If I can figure out how to edit that out, I will. But to be honest with you, I probably will not be able to figure that out. So, it's okay. It's going to happen. That's part of life. All right, so anyway, so matter is composed of, all right, the first thing is called a pure substance. All right. Well, if I can spell correctly today, that's also going to happen, guys. Let me grab my white out. Here we go. All right. All right, so pure substance. And there are two types of pure substance. The first one being elements, which you can find on the periodic table. There are over 100 of them. I think the last one, I think it's up to 118, 119, and they are finding new ones all the time, okay? So, elements or compounds are also considered a pure substance. So, now what makes these two different is that elements exist by themselves on the periodic table. A compound is two or more different elements bonded together. Okay, so the best example of that is something you guys are familiar with, water, H2O. Okay, that would be an example. Whereas hydrogen and oxygen by themselves would be considered elements. When they're bonded together in a set ratio, they're considered a compound. All right, so that's one thing that matter is made of, pure substances. The second thing that matter is made of is mixtures. So I'm going to take my line across here. All right, and there are actually two types of mixtures. All right, the first type of mixture is called heterogeneous. All right, and heterogeneous mixtures are mixtures where you can easily pull apart and separate components. So for instance, like a pizza. If you did not like the pepperoni on a pizza, you can pull that off. If you don't like wanted cheese on the pizza, you could pull that off. Also, a salad is another example. If you don't like the tomatoes, you can take those out. If you don't like the croutons, you can pull those out. Although, if you don't like croutons, that's a little crazy. Love croutons. All right, so just some examples of this would be pizza or a salad. Okay, that's examples of a heterogeneous mixture. Okay, now the other type of mixture is a homogeneous mixture. All right, and how this one is different is that the components, usually you can't distinguish one from the other. Now there are always ways to separate mixtures, okay, always. But so an example of this would be like when you guys squirt like these little water flavor things in your water. Even though your water and the flavoring itself is a mixture, you could potentially, through some sort of process, reverse that and separate them, but they appear together as one. Okay, so some examples of this would be like mixing, I'm gonna call it flavors. Mixing flavors in your water. You can't really distinguish each part from itself, okay, but there is a possibility to reverse it. All right, so I'm gonna leave this here for just a second, and you can pause the video now. All right, so now we're gonna move on. All right, so matters definition. So in order for something to be considered matter, its definition, it's gotta have two things. One thing is it has mass. Okay, meaning you can measure how much compactness it has within it. Mass is similar to weight, but I don't want to call it weight because then that confuses students. Weight can actually change depending on where you are in gravity, whereas mass does not ever change. And the second thing, it has mass and it takes up space. So anything is matter if it has mass and takes up space. All right, you can pause that for just a minute if you need to. All right, we're going to come off over here on this side. Matter is made of atoms. Okay, matter is made of atoms. They are the smallest unit of matter. An analogy to this, you can think of it like the cell is the smallest living unit, the smallest unit of any living organism. Well, atoms are the smallest unit of any type of matter. And elements are made up of the same type of atom. All right, we're going to move on. Okay. I'm going to try to, we have to kind of come around here. All right, so matter is classified or grouped. And I'll write that in there too. Or grouped by its state. Okay? Oh, I'm sorry, you can't see that. By its state. And there are 3 states of matter: solids, liquid, and gas. And those states can change. We're going to talk about that in the next unit, how they can go from one to the other. All right, so if you need to pause and keep up with me, that's okay. Go ahead and pause it now. All right. Next thing you need to know is that matter, all matter, has properties. So all matter has properties. And there are two types of properties. There are physical properties of matter, and there are chemical. All right, and if you did your notes yesterday, which you should before you watch this, you had a really, really long list of all the different, and they're not all, but I should say the common ones, the common physical properties and common chemical properties of matter. I gave you a list with their definitions, okay? All right, so I'm going to give you just a second. Pause this if you need to. All right, so now let's just zoom out and recap really quickly. Okay, there's my white out of the way. All right, so matter is made up of atoms. They're the smallest unit. And the definition of matter, two things. Matter has to have mass, and matter has to take up space. You can also call this requirements. So matter has physical and chemical properties. It can exist in three states: solid, liquid, or gas. And it is composed of either pure substances, which are elements and compounds, or it's composed of mixtures, which can be heterogeneous mixtures or homogeneous mixtures. All right, so now the next page that we're going to be doing, we are going to look a little more closely at elements, compounds, and mixtures, and we're going to draw some diagrams together. So if you did not use colors on this one, that is fine. But for the elements, compounds, and mixtures, you are going to need about 4 different colors. Okay, it will just help you to distinguish what is in the diagrams. So pause the video if you need to and go grab some colors. All right, so I'm hoping you grab some colors. So we are just going to draw some diagrams that will hopefully sort of help you when it comes to distinguishing elements, compounds, and mixtures. So we're going to start with elements. All right. You're also going to do an assignment tomorrow that has you count elements. It's going to have you, I think it has you distinguish elements from compounds from mixtures. So these are going to come in handy. All right, so what we're going to do, we're just going to draw a little 4 square box, so that way I can put 4 different drawings in it. So make it fairly big. Okay. All right. So here we go. Okay, so first off, elements exist on the periodic table. So if it is not on the periodic table, it is not an element. All right, so some examples of elements would be sodium, fluoride, boron, oxygen, hydrogen. Okay, the thing you need to know about elements is that they can exist alone, meaning they are just an atom, or they can exist as a molecule. Okay, and we do have words for this. So if they exist as an atom, we call it monatomic. Ooh, got close there. Okay, we call it monatomic. And if they exist as a molecule, we call it diatomic. And those prefixes tell you what they mean. So on their own, that MON, that's a prefix meaning 1. That DI, that's a prefix meaning 2. Okay? So notice like hydrogen is a diatomic element. It's a molecule because it exists together as 2 hydrogens bonded. Same as oxygen. Whereas sodium can exist by itself, so it's just an atom or it's called monatomic. All right, so now, the key thing that you're looking for with elements is that they're all going to be the same. So for instance, this would be an example of elements. They're also not going to be touching. They're not going to be bonded together unless they're bonded together as the same color. So for instance, like if I had a triangle here this side, okay. With a triangle here. See how they are touching? That shows that that is a diatomic molecule because they have the exact same coloring. Looks like a little slice of pizza or a Dorito. Okay. All right. And then here's just another example of elements. They're usually the easiest one to spot. So pause the video if you need to and get those diagrams before we move on. All right, so now we're going to talk about compounds. Okay. Draw my little box here. So what you need to know about compounds is they are always two or more different. That's the key word here. It's got to be two or more different elements. Okay, so up here in your elements, you notice you've got two bonded together. But they are the same color with the same pattern. So they are still representing the same type of atom. Whereas down here with compounds, it's going to be a little bit different. So some examples of compounds, you guys would know table salt, which is sodium chloride, okay, which is where sodium and chlorine are bonded together. The interesting thing about compounds is that they actually retain separate properties than their elements. So for instance, sodium and chlorine are both poisonous on their own, okay? However, when they are chemically bonded together, they're perfectly safe, table salt, and you can eat it. So it's pretty neat. Another one that you're gonna see a whole lot later on when we get to life science is glucose, C6, H12O6, which means you have 6 carbons, 12 hydrogens, and 6 oxygens all bonded together. It's a very, very large molecule. Very, very large compound. And then another one, as always, H2O. You guys pretty much all know about water. All right, so now to show this, it can be done in a couple different ways. So the first way is that you could show, using the same color, you could show two different shapes touching. Okay, the touch in between them shows that they are bonded together. But see, up here, these elements have the same shape. Whereas down here, even though they're the same color, that circle would represent one element, that triangle would represent a second element. So it's different elements bonded together. Okay, another way they could show this is by using the same shape, but different colors. So you can have a large color bonded with two smaller colors, but they are same shape, but different colors. Okay, that is also going to show a compound. But then you notice that these are not mixed together, like they're not bonded to themselves. This is a bond, this is a bond. All right, and let's just do one more, just so that we have 4 in every box. All right. Okay, so that shows compounds. All right, pause it right here if you need to before we go on to mixtures. Okay, so now with mixtures, this is going to contain 2 or more substances. And mixtures can actually be, you could have elements, you could have compounds, you could have other mixtures. but mixtures can be broken down. And usually mixtures are going to retain the properties of their substances. So meaning if you put salt in a mixture, it's not going to automatically break apart and become poisonous again. The fact that it's chemically bonded together, it's still going to retain that safeness. All right. I think my boxes are getting bigger as I go down. Okay. All right, so a few examples of mixtures. The air. Our air is a mix of nitrogen, oxygen, carbon, and a few other small trace gases. And we're going to talk about that once we get to our earth science unit. I gave you the example earlier of pizza. Salads are examples of mixtures as well. Things like concrete. Concrete is an example of a mixture too. All right, so how to show mixtures. So let's say we've got this element, and this one, but then we're gonna add in this element and this element too, and then this one over here, but I'm not done yet, and I wanna add in some more. Okay, so notice how you've got different colors, okay, even though it's the same shape, but none of them are bonded together, they're not touching. Okay, so another example. Let's take the boxes that we did above in the compounds. So we've got our boxes. Okay, and let's take our green circles that we put in the top for the elements. And then let's just take those little circle squares. All right, so again, we have another mixture. You notice you've got different compounds and you've got some elements thrown in there, but they're not all bonded together. All right, and let's just do one more. Let's bring back the little Dorito looking elements from the top. Okay, and then we'll bring in some diagrams of elements, compounds, and mixtures. Okay, so before I let you go, funny story really quickly. Yesterday, I actually made this entire video, okay, like the whole thing. And in the middle of it, my phone started ringing. I got a phone call, and I did not know that when you decline the phone call, that it stops your video. So I literally taught for like 15, 20 minutes, and it didn't record any of it. So I had to redo it. It was just a Monday, I guess. You know, that just sometimes happens. But anyways, I hope that this will help you with your work. And as always, feel free to reach out if you have any questions. Bye, guys.